Hello, Year 8s. So you are in your Introduction to Science booklets, page 13, and today we're going to focus on how do you design a good science experiment. So let's get going. Okay, so before we look at the experiment that you are going to design, let's focus on some key words when we are designing experiment. And what you're going to do is I'm going to explain these, and once I've explained all 5 of these, we're going to pause the video and you will have 5 minutes to copy these down in silence. So let's have a look at the word accurate. Now, obviously, as a scientist, it's very important that you are accurate. So let's have a look at the definition. So we define something that is accurate as a measurement that is close to the true value. So if I'm doing an experiment and I know that the value I should get is 2 and my result is close to 2, then I know that I am being accurate. I like to picture this with this bullseye in the target. When I hit the bullseye with the arrow, I am being accurate. Now, this causes slight confusion because what then does the word precise mean? Now, if you have a look at this dartboard, these darts have been thrown very close together, so it's very precise, but interestingly, because they were trying to go for the bullseye, it wasn't accurate. So you can be precise and have all your results close together and still not be accurate. So the definition of precise is measurements that are close to each other. Now, slightly different to this, sometimes you'll hear us talk about precision instruments. So if you have a beaker that goes up on the label from 0 to 50 to 100 to 150 to 200, because it's not showing all the bits in between, it's not a precision instrument. But if I give you a measuring cylinder that shows you each milliliter on the measuring cylinder, then that is a precision instrument. We also like to use the term repeatable. Now, if I have to say something again and again and again, I'm obviously repeating it. In an experiment, if I get the same results again and again and again, then I can say that this experiment is repeatable. What is really important in this definition is it has to be by the same experimenter. So if you do the experiment once, twice, 3 times, and the results are all the same or very similar, then your experiment is repeatable. Now, you might do an experiment and think you've got a fantastic result, but I do your experiment and my results are completely different. That is a problem in science, and sometimes scientists have made claims to things such as the MMR vaccination can lead to disabilities without that experiment being reproduced by another scientist and causing mayhem because that scientist had made that statement. A lot of people thought that it was dangerous to give their children the MMR vaccination. And we've since found that that's absolutely rubbish, and the MMR vaccination is a safe vaccination. So, for a good experiment, it needs to be reproducible. And by that we mean that if somebody else does the experiment, the results are similar to the results that you got. And finally, reliable. So if the results are both repeatable and reproducible, then we can say that our results are reliable. Pause the video and you have 5 minutes to copy these down in silence. Okay, welcome back. So what we're going to do today is we are going to design an experiment with a suitable method to investigate something. And what we're going to do is we're going to see what makes a difference between a simple method, which will be a grade 3 level, and a grade 7 level. So it says over here, all experiments have an aim and a method. Brainstorm with your table what makes a good method. So if you had to do an experiment right now, how would you know that the method is a good method? So if I give you a method from one person in your class and I compare it to another person in the class, how can you tell when the method is good? Pause the video and you've got 1 minute to discuss it in your pairs. Okay, right, so I'm not sure what you came up with in your groups, but let's listen carefully and think about how does your answer compare to my answer. So the first thing is it must include all the equipment you need right at the beginning so that I have everything ready to go. It must also have a bullet point for each step. So just like a Jamie Oliver recipe, which is written so clearly that I can copy what he says and cook exactly like Jamie. Now that's because his method has been very, very clear. So I want you to set this up as a bullet point, one instruction at a time. Now, if you have any chemicals in your experiment, it's very, very important that you clearly state what mass or volume of the chemicals you need, because otherwise I won't know in the experiment when I copy your method exactly how much I need to add. So clear is kind. Now we've been talking about the independent and the dependent variable, and the independent variable is what you decide. So you need to make sure that you show very, very clearly the range of your independent variable. So for example, if you are using different color M&Ms, you will state which color M&Ms you are using so that I copy the experiment exactly as you have. Or if my independent variable is looking at something at 10 centimeters, 20 centimeters, 30, 40, and 50 centimeters, what you can see there is I've got at least 5 independent variables. So a good range is always found in a good experiment. And then you must clearly describe how to measure what you're finding out. So if we're looking how quickly the color runs in the M&Ms, you are going to need to ask yourself, how am I going to see how quickly it is? So am I going to time how long it takes for the dye to reach the middle of the bowl, for example? Or in the example that we have on the screen, your independent variable is different points, and then obviously measuring something at those specific points. And it's always a good idea in your method to say that you need to repeat your readings 3 times, because the more we repeat it, the more reliable they are. If we suddenly get an odd result, then we know that something has gone wrong. Now, if we only did the experiment once and that one result was odd, we would be basing our whole conclusion on that odd result. So by repeating it, we can see if we get any odd or anomalous results, which means that we need to either repeat it or we need to not count that odd or anomalous result. Okay, now what we are going to do is in your booklets, I have set out different sections for the experiment that I have chosen for you. So I'm going to explain the experiment to you, and from that, using what you have learned over the past couple of lessons, I want you to fill out the aim that clearly shows what the independent and the dependent variable is, and it's usually something like to investigate how da-da-da changes with da-da-da. Hypothesis is what do you predict will happen? In the planning, now I've broken this down to help you. So in your experiment, I want you to work out what is the independent variable and put it in this box here. What is the dependent variable? And list in bullet points, what are the control variables in this experiment? Are there any hazards and how should they be avoided? And then there's some tips here. How many times will you repeat the experiment to calculate an average and make your results more reliable? And design a table for your results and think what type of graph you might use. Now, you are also going to need to list your apparatus, and then we are going to get onto the method. So what I'm going to do is I'm going to explain to you the experiment, and then you are going to write it in your booklets as clearly as possible.